Welcome to this lesson. This lesson is about compound inequalities. I'm sure that you have learned how to solve simple inequalities, where you have just one inequality symbol. What I mean by that, less than or greater than, less than or equal, greater than or equal. But before we get to talking about the compound inequalities, we need to review unions and sets, unions and intersections of sets. So what is a union of two sets? So let's define that. The union of two sets, A and B, is all elements contained in either A, B, or both. For example, if set A contains the elements 1, 3, 5, 7, and set B contains the elements 2, 4, 6, 8, then the union, which we denote the union by A, U, B, so the union of the two sets will be everything in A or B, which means everything that's contained in both. And remember, or, the meaning of or in English includes both of them. It's not quite the same as the meaning of or. Oh, I meant to say in mathematics means both, and not the same as in English means one or the other. So the union of them, you're going to take one, everything in A and B. 1, 2, 3, 4, 5, 6, 7, 8. So that would be the union. So I think the union is the bigger set. And another example for union, if you have, let's say, using a Venn diagram, this is set A, and this is set B, and I have the letters R, S, T in A. So here A is R, S, T. And let's say we have U, V, and T in set B. So those are the elements in set B, T, U, V. Then the union, A union B, would be the set containing everything in A or B, and that means everything in both of them, so it's going to be R, S, T, U, V. So the union is going to include everything in there. R, S, T, U, V. All right, so that's about the union. The intersection. So let's define the intersection next, because we're going to use those concepts as we solve compound inequalities. Okay, so let's define intersection. The intersection of two sets, A and B, is every element that is contained in both A and B. That means shared between set A and set B. So it's what's common to both. So if set A is equal to, let's say, ABC, and set B includes B R S, then the intersection, which denoted by A, upside down U, that means intersection B, is what's common to both, what's shared. And you could see the element B is shared between both of them. And if they don't share any elements, then if they have no elements in common, that means the intersection is the empty set. Intersection A, intersection B is the empty set. Or another symbol for the empty set is those braces with nothing inside them. All right, so now that we have defined what union and intersection are, we're going to go and start with some examples on solving compound inequalities using OR. Okay, so before we do that, if you have something like, let's say, 2x plus 3 is greater than 12, this is called a simple inequality, because this inequality, includes one inequality symbol, which is the greater than. And we know how to solve this kind of inequalities. But for a compound inequality, it includes two of those symbols. For example, 2x plus 3 is greater than 12, or x minus 2 is less than 7. So this is called a compound inequality because we're taking this simple inequality and this simple inequality and joining them together with the word or. So it makes a difference whether you use or and. Or is what we use when there is a union, when we want to find the union, and when we want to find the intersection. So you need to associate or with union all the time and with intersection when you solve compound inequalities like that. So the way to solve them is you need to solve each one of them and then take the union, because or means the union. So to solve this one, I'm going to add -3 to both sides. Then I get 2x is greater than 9. And then I divide both sides by 2, so x is greater than 9/2. Or, so this is part of the solution of the compound inequality. Now we need to solve the second one, so add 2 to both sides. That gives you x is less than 9. And that would be the second part. So we have x is greater than 9/2, or x is less than 9. Remember that, this is the algebraic solution. But we're often asked to represent the solution in interval notation and graph the solution. What I suggest is that we graph the solution first, because we're going to be looking for the union, and I think we get that by looking at the graph. So x is greater than 9/2, so let's say that is 0, and 9/2 is 4.5, so let's say there's 9/2 over there. X is greater than 9/2, so 9/2 is not part of the solution, but all numbers greater than that are. So all numbers greater than 9/2, I represent them by this line. X is less than 9, and so let's say there's 9 right there. And x is less than 9. It's not 9, but it's less. So it's all the numbers to the left of 9. And if you are thinking that you want to take the union between this first solution and the second solution, the numbers contained in the blue line, and union the numbers contained in the red line, then you're going to take what's contained in one of them or the other or both. So look at what's shaded. So to find the union, then you're going to look at everything that's shaded once. It could be once. And so shading, it looks like we've shaded the whole line either once or twice. Notice that if we're looking for the intersection, we look at the part that's shaded twice, but the OR means find the union. So the union is everything that's shaded on the number line. So we're going from negative infinity to infinity, and that would be the solution in interval notation. Remember that for negative infinity and infinity, we have to use the parentheses because negative infinity and infinity are open-ended. We don't know exactly what negative infinity and infinity are, so we can never include them in the solution. So we can never use brackets. We have to use parentheses. So we're done for this one. Let's take an example. Probably should take another example with greater than. Another example like this one with the or, I meant to say. Okay, negative 3y minus 5 is greater than 4, or 4 minus y is less than or equal to 6. Again, it's an OR statement. Remember, you have to take the union once you solve each simple inequality. So to solve this one, I'm going to add 5 to both sides. Then I'm left with negative 3y on this side is greater than 4 plus 5 is 9. Now I need to divide both sides by negative 3. But you have to remember, every time you divide by a negative number, the inequality by a negative number, you're making a true statement a false statement. So the greater than should become less than. So you need to have your eraser handy and change your inequality symbol whenever you divide or multiply by a negative number. So that's going to give us y on this side is less than 9 divided by negative 3 is negative 3. So that's the first part of the solution, or. Now let's solve this one. I'm going to subtract 4 from both sides. So negative y is less than or equal to 2. And now I need to change the negative y to positive y. So again, if I multiply both sides by negative 1 to change that to a positive y, I'm making this statement a false statement. To correct that, the less than or greater than, because I'm multiplying by a negative number, should become greater than or equal to. So this becomes y is greater than or equal negative 1 times 2 is negative 2. So I have the two solutions here, the two simple solutions joined with or. So it means I have to graph them and take the union. Y is less than negative 3, so that's negative 3. Not equal to negative 3, so I make it an open circle to indicate that the negative 3 is not part of the solution, but all numbers smaller than negative 3, which they're located on the left of negative 3, are included in the solution. Y is greater than or equal to negative 2. So that's negative 2. Greater than or equal, that means you're going to shade that circle in to indicate that the y could be equal to negative 2, so the negative 2 is included. And it's going to be greater than. So I'm looking at the union. To take the union, I'm going to take everything that's shaded, because everything is included either in A or in B. So my solution, this is the algebraic solution. And this is the solution in interval notation. So you're going to take this interval that's going from negative infinity to negative 3. We can never include negative infinity, so use parentheses. The negative 3 is not included, so we're going to use parentheses as well. And we have to put our union symbol because we're taking the union with the other set. And here I'm going to include negative 2, so I have to use brackets to show that the negative 2 is included. Put a comma, and that's going all the way to infinity. And we always have to use parentheses at infinity. So this will be the solution in interval notation. Okay, the next thing we're going to go to is deal with solving absolute value. I'm getting mixed up here. Compound inequalities, I should say, when we have and, so when they're joined with and rather than or. Okay, so let's take this example, negative 2x is less than 6, and x plus 5 is less than or equal to 7. And so remember, they're joined with and, so that means I'm going to take the intersection when I'm done solving both inequalities. So let's solve this one. To solve this one, I need to divide by negative 2. Remember, whenever you divide by a negative number, I'm going to write my original inequality here. So whenever you divide by a negative number, you need to change the inequality symbol. So this becomes greater than. And so that gives you x is greater than 6 divided by negative 2 is negative 3. And here, you're going to add negative 5 to both sides. So we get x is less than or equal to 2. And so that's the algebraic solution. And now we want to graph it and then write the solution in interval notation. X is greater than negative 3. So that's 0. That's negative 3. Does not equal to negative 3. So that means we have an open circle. Greater than, we go to the right. And x is less than or equal to 2. So if that's 2, less than or equal means that we have to shade it in. Everything includes that 2. And less than, we go to the left. So now if you look at the blue line and the black line, and we're thinking of and means intersection, we have to take the intersection where both of them are shaded, because the intersection includes elements that are in both, shared in both. That's what the meaning of intersection. How do we write this in interval notation? We're going to start from this negative 3, but notice that the negative 3 is not included, so we use parentheses, put comma, and we're going to 2, but the 2 is included, so we have to use brackets. So that's the solution in interval notation. And now, if another way I can write the solution instead of having it like this, I can say the solution is x. X has to be between negative 3 and 2. So x is greater than negative 3, less than or equal to 2. So that would be another way of writing the algebraic solution. There is another representation of compound inequalities with and I'm just going to show you this one last example on that. So let's say you have 2x minus 3, and that is greater than or equal to negative 7, less than 12. This is another way of writing compound inequalities with and. So if you see something like this, you know we're using and. One way to do it is to say, well, this is one simple inequality. And so you just take it like that. Negative 7 is less than or equal to 2x minus 3. And this is another one, which is 2x minus 3 is less than 12. And remember that this means and, so you have to put the and then solve it that way. So you can translate it this way, solve each one of them. Or you could, there's an alternative way that you could use, so I'm going to rewrite it here and show you. You could isolate the x in the middle, because x, you want x to be between two numbers, and then you find your solution. So first step to isolate x is get rid of the negative 3. So I would add positive 3 to all the three terms. That gives me on this side negative 4 is less than or equal. This cancels out, so now I have 2x in the middle, less than 12 plus 3 is 15. And now to get x by itself, I'm going to have to divide everything by 2. So I'm dividing by a positive number. There's no need to switch the inequality symbols. If I'm dividing by a negative number, for example, if this was negative 2x, then I have to divide by a negative number. Then both inequality symbols must be switched. So this becomes negative 2 is less than or equal. X is less than 15/2. And if you want to graph it, notice that we always focus on the x. So the x is greater than or equal to negative 2. So that's negative 2, greater than or equal to negative 2, less than 15/2. 15/2 is 7.5, so it would be somewhere there. And not including that, but the numbers to the left. Notice that because it's and, we're just taking the intersection right away. X between those two numbers, there it is. Negative 2, I should say, and 15/2. So the interval notation would be going from negative 2, including negative 2, so I use brackets, comma, going to 15/2, but it's not including 15/2, so that would be parentheses. So that would be your solution in interval notation, and this will be your algebraic solution. Okay, see you next time.